Alright, limit properties. I'm not going to try and explain these or even show you them right off the bat. We're just going to use them because usually those like really mathy theorem, postulate type definition things that the book gives you, well, first of all, they're in your book, so I don't need to show them to you. And second of all, they're really confusing and annoying, so it's way better just to show you how to do the problems you have to do and get on with it. Alright, so here's what the problems look like. They're weird because they don't tell you the function. So what they'll say is they'll say given, and then this stuff. So you'll notice that they've told me what the limit of the function f is. They've said it's 6. But they didn't tell me what the function is. They didn't tell me if that's x squared or 2 times x or whatever. They just told me that as x approaches 3, the limit of f is 6. Same thing for g. They didn't tell me what g is, whether it's got x's in the numerator, denominator, blah, blah, blah. All they told me is that as x approaches 3, that g approaches negative 2. What this allows you to do is mix and match these in the problem. Now you'll notice they're also both approaching 3. It's not like they gave me the limit of, as x approaches 3 of f and then they put a negative 3 here or something. They're both approaching 3. And what that's going to allow us to do is break it up. So here's what, using limit properties, now they're asking for the limit as x approaches 3 of f plus g. Well, it turns out all you have to do is say, oh, well, really, that's the same thing as the limit x approaches 3 of f plus the limit as x approaches 3 of g. So there's just a rule in your textbook that says, hey, if you have the limit of a sum, you can break that up into the limit of the left thing plus the limit of the right thing. It's kind of like distribution in algebra. Limit of f, limit of g. So that's what's going on here. Now, but you'll notice that each of these is actually what they already gave me. They already told me that the limit as x approaches 3 of f is 6. And they told me that the limit of g approaching 3 is negative 2. So I just get 4. And you'll notice that I could have just gone straight up here and said, oh, f plus g, that's 6 minus 2, is 4. So that's kind of just depends on your teacher how much work you're supposed to write down. You know, do you have to break it up and write down limit as x approaches 3 of f plus limit as x approaches 3 of g? Or can you just say, oh, 6 minus 2 is 4 and just write down 4 and not write down anything else? It just depends on your teacher. But this is a limit property. And something similar is going to happen with derivatives and integrals later on, which is we can add and subtract things together. So if you have the integral of something plus something, it's really just the integral of something plus the integral of something else. It might be going over your head right now, but the point is, calculus is going to be full of situations where you're doing something to two things added together, and you could just separate it out and do that something to one of them, then do that same something to the other one. Same is going to happen here. Limit as x approaches 3 of f times g is just the limit as x approaches 3 of f all multiplied times the limit as x approaches 3 of g. So that's just going to be, let's see, this one is 6, this one is negative 2, so that's going to be negative 12. Would you bet that there's a rule for division as well and multiplication and stuff? Well, sure enough. I'm not going to write out all the limits this time. We can just write, hey, well, if it's 2 times f over g, and by the way, this is the same problem I gave you a second ago, so these are the same numbers. F is 6 and g is negative 2. So it's going to be 2 times the limit of f, which is 6, divided by the limit of g, which is negative 2. All we're doing is plugging and chugging. So it's going to be negative 6. And 2g squared, gee, what a shock. There's a rule for exponents also. So all we have to do is 2 times, and then, now keep in mind, the squared only applies to the g. There's no parentheses around 2g, so it's 2 times, then whatever g is, which is negative 2, squared. So that's going to be 2 times 4, which equals 8. Easy peasy, right? And just for kicks, we'll break these puppies out. Now you'll notice that this time we replace g and f with just x. So this is kind of like a polynomial, right? But when you're taking the limit of a polynomial, really, because we've done that a bunch already in these videos, but what we really were doing was taking the limit of 2 times the limit of x. Anyway, so this is the fancy thing we could do. We could say, you know what? Something minus something is really the limit as x approaches 3 of 2x minus the limit as x approaches 3 of 3. Now, I'm not only showing you this because you may have a stickler teacher who requires you to do this, kind of like the logarithm rules, where you can break up logs of products into sums and that kind of junk. There's a particular kind of problem where you decompose. Then there's another rule that says you can move a constant out front. So we can take this 2 and move it out front. So this is going to end up equaling 2 times the limit as x approaches 3 of x minus the limit as x approaches 3 of 3. This would be the answer to the question I proposed. I don't know if you'll ever have to do this or not. It just seems this is just a type of question that some teachers in some books emphasize. So we took something that looked pretty normal, like, hey, let's just plug in 3. And we sort of mathematically we were real sticklers for the math and the logic and all that, and we broke it up into totally separate limits. So 2 times the limit as x approaches 3 of x. And the rule here is we're trying to get it down just the limit as x approaches 3 of x. Any exponents we want to put outside, that kind of thing. All right, same thing on this one. We could break this up into the limit as x approaches 3 of x, quantity squared, so we're basically putting that squared outside the limit, and then plus 5 times the limit as x approaches 3 of x. Once again, it's unlikely you have a teacher that's a stickler and makes you do these, but there's just one notch more complicated than the type of problem we did first in this video, which was where if they give you the limit of f as x approaches 3 and limit of g as it approaches 3, then they can make you find the products and all that, those limits as well. All right, so that's limit properties. Addition is addition, subtraction is subtraction. These are very boring, very straightforward. Nothing like derivatives, which we'll come to soon enough.